I'm Chris Larsen. I'm the CEO and co-owner of Larsen Motorsports. I've been building jet cars and jet engines for over 2 decades. We push our engines in the jet cars harder than they were ever pushed in the aircraft application, and we've made a bunch of mistakes through the years. What happens when you make those mistakes? Figure out how to fix it. That's when we call the specialists. There's a bunch of areas and components in jet engines that we could talk about, but today we're talking about the afterburner section of the engine, and in particular, the part that we call a flame holder. That flame holder in a racing application lives in an extremely volatile environment. The airflow alone is over 1,800 miles an hour as that gas path transitions through the afterburner. The flame holder lives also in an extremely high temperature environment that is quite often over 1,000 degrees Celsius. The flame holder is made out of materials that are made to take pretty high temperature, but how do we add that extra safety margin? That's been done with thermal coatings. Whenever we need something coated, we head over to Florida Tech Center for Advanced Coatings just a couple miles away, and they take care of all of our needs. Today, we're going to have you meet a couple people that work with advanced coatings. Then we're going to show you how we use our jet dragsters for high performance research applications with thermal coatings. First up is Frank. He's the man when it comes to programming the machines and spraying the actual thermal coatings.
My name is Frank Acanero. I've been in the thermal spray industry for about 20-25 years. Thermal coatings are good in various different markets, depending on what you're trying to do. For example, with us, here we're working mostly with ceramics, so we do a lot of thermal barrier coatings on land-based turbine engines that make electricity, and we protect the parts themselves by coating them with 2 layers of coating. That helps the parts in the engine from overheating and any corrosive things that are going on in the engine, like fuel, burning the fuel. And it helps also keep the engines more efficient. So they burn less fuel, they're more efficient that way. And if something happens inside the engine, it would damage the coating rather than the actual part. And if the coating starts to fail, that's a good sign for the person who running the engine can know that. So something's either gone wrong with the coating or gone wrong with the engine in some form. The variety of things that we can coat can range anything from wood. I've coated an apple, in all honesty. When I was working for Praxair, we did a little logo where you could see the flame hitting the apple. And it was to show that you could spray something as simple as zinc on an apple and then peel it off the apple, and you just have the coating, and the apple is unharmed, so to speak. There's no charring or burning of the apple. You just get a nice mold of the apple. From the perspective of Florida Tech and what they want to accomplish with thermally sprayed coatings is they're in the industry now where it's pretty high visibility. We're around the Space Coast. Dr. McKay has been, she is an astronaut. She has been involved with NASA in numerous projects, and they're forever putting coatings on the space shuttle for various different reasons.
Let's meet the woman behind it all, Dr. Mary Helen McKay, a pretty interesting woman with a lot of accomplishments. She has actually worked at NASA as an alternate payload specialist astronaut. Take it away, Mary Helen.
I am Mary Helen McKay, and my title here is that I'm the director of the Center for Advanced Coatings. I work at Florida Tech. I'm one of their professors in mechanical engineering. We formed the new Center for Advanced Coatings partially because I've always felt that coatings were very significant for the world. Back, the earlier research that I did was involved in putting corrosion-resistant and wear-resistant coatings on, like I said, things like truck beds and tanks and whatever. And so we hope to bring some of that capability to this community. I know this community has to use them. Coatings are so valuable because it's the only way, as you know, that you can get a material to actually operate in an engine above its melting point, is if you put a coating on it. Well, to me, hands-on is absolutely necessary because it's the world we live in. I mean, you can imagine or see on a computer the design for something, but until you've actually tweaked the knobs and set the parameters and worked on it sometimes for years until it finally takes shape, I mean, then you finally have accomplished something. It's there, it sits there, it turns on, it runs, and if you've done your job right, it actually provides some advantage to the world and the earth. And when they get into their jobs and they're actually dealing with other people and they're building equipment, if they've never actually touched equipment, then how can you expect them to have any idea of what it takes to design one? Approaching it from the research side, the first thing that we'll do is, we'll weigh it, we'll measure it to make sure that we know exactly what it's like before we even begin, because one of the most important things with regard to research is your baseline. You have to know what you started with, otherwise you don't know if you've changed anything. So that's the first thing that Frank will do, is all of the weighing, measuring, and characterizing of it. And then we're going to put different coatings on different parts of it. Again, leaving one section of it bare, because that's again the baseline flame bucket. So then we will put different coatings on other parts of it, and over time we will measure, since we've measured initially, we will measure to see if there's been any loss of the coatings, like loss of weight because of coating coming off, or sometimes you will even get a weight gain in a coating because it's taken up oxygen or nitrogen and formed compounds, and so it might even grow in thickness as opposed to shrink in thickness, depending on, it could pick up all kinds of elements from the engine, from your fuel and stuff, so we could find the coatings either growing or shrinking. The real goal is to expand the lifetime or increase the lifetime, and that's why we'll put different coatings on so we can see which ones actually work better. And then we're going to end up at some point, especially with you guys' advice, figuring out how to do it in a economical fashion and a way so that if they need to be repaired, the coating being there is not a problem.
So now that we know who and why, let's learn exactly how advanced coatings are applied.
So this is the flame holder I got from Larsen. The first thing I do is I usually go through it and I'll inspect it, and I'll take some measurements so I know how thick everything is and where I'm going to add coating. So my plan is to add coating to the entire part. So once I get it all measured and everything, I'll put it in a grip blast cabinet like this. We'll grip blast it. It used to look like, see if I can find a little dirty spot like this. You can see where it's kind of rusted or heat has gotten to it. So what I do is I put it through the grip blast machine, and I try to get it as clean and as bright and shiny as I can, because it gives me more surface area with the metal for the coating to stick. Once I do that and it comes out of the grip blast cabinet, then I come over to the booth. And once I'm in here, what I will do is I will generate some type of fixture or holder where I can hold that thing in one spot. And I like to do fixturing, so if I have multiples of these, I have it, or it's all repeatable. I can put it back in the same spot every time. And then what I do is I take this guy right here and I program him with the gun or the torch on the end to basically go around and spray all the angles and everything on the part. And once that's done, I put down 2 coats. I put down a bond coat and a top coat. So what I have to do now is I have about 1/4 of it where I have it sprayed. So now I'm going to go in, after it cools down, I'll rotate it to the next point, and I'll complete the program that you just saw running. And then I'll do it a 3rd time, and then it'll be coated completely with bond coat. And then I'll do the same procedure for the top coat. We'll basically turn the part white when I'm done with it. So I've sprayed this section of the flame holder. So now I'm going to take it, I'm going to unbolt it, I'm going to spin it, and then we can spray the next section of the flame holder. spots. I don't know if the camera will pick it up, but there's a shadow right here from some overspray. So what I'm looking for is just basically a nice even coverage, just as if you were spray painting it. Okay, now we're ready to spray this section. So now I just repeat that process. I'll spin it one more time. I'll do the same process, and then I'll repeat the same exact process for the top coat. The only thing different between the bond coat and the top coat basically is speed and parameters. So I'll set my gauges differently for top coat, and I'll set the robot speed differently for top coat. And then once we do that and we get to the thickness we need, that's it, we're done.
The flame holder is back from the Center for Advanced Coatings. Brian, well, he's up inside the afterburner installing the flame holder, and in just a few minutes we're gonna fire this baby up and start our testing.
Hey guys, so we're out here at Larsen Motorsports. Florida Tech has done a great job coating my flame holder, so now I'm gonna put it to the test. Up on the flame holder, so now what we're going to do is let her cool down back there. Brian's going to go in there, take the flame holder out, see if that thermal coatings that they did so well at Florida Tech held up, and if it did, we're going to start our research. So stay tuned.